All right, we're going to dive into a concept that, well, it pretty much powers our entire modern world. It's this idea that is so successful, so deeply baked into everything we do online, that you probably use it hundreds of times a day without ever thinking about it.
So think about it for a second. Your bank, your social feed, that thing you just bought online, they seem totally different, right? But underneath it all, they're all built on the same incredibly strong and honestly really elegant foundation. It's the invisible architecture that keeps our digital lives from just falling apart. And the answer, believe it or not, goes all the way back to 1969. It's a concept called the relational model. It's this way of organizing data that was first dreamed up by a computer scientist at IBM, and it's turned out to be one of the most important ideas in the history of computers, period. But to really get why this was such a game changer, you have to understand the world it replaced. Because before the relational model, trying to manage data was, to put it lightly, a complete and total nightmare. So before this guy Edgar Cod came along, data was just stuck. It was locked up in these rigid, custom-built systems. If you wanted to ask a simple question like, hey, which customers bought this specific product, you'd have to write a whole new complicated program just to untangle this mess of files. It was slow, it was full of errors, and it was just inefficient. Cod's paper changed everything, and by the 80s, everyone was scrambling to catch up. Cod's solution was just genius in its simplicity. He basically said, look, any data, I don't care how complicated it is, can be represented in one single way, as a bunch of tables, or, as he called them, relations. So the main building block here is the relation, which, let's be real, we all just call a table. It's a grid, like a spreadsheet. And in this model, that is the only place data gets to live. Each row in that table has a fancy name, a tuple, but it's really just a single, complete record. So think of one customer in your phone's contacts or one t-shirt in an online store's catalog. That's a tuple. And then each column is an attribute, a specific piece of info about that record, like a first name, an email, or a price. The key takeaway here is that everything gets boiled down to this really simple, predictable structure: tables, rows, and columns. That's it.
Okay, but how do you keep things organized? To make sure every single row is unique, so you don't have duplicates messing everything up, each table has to have what's called a primary key. Look at that customer ID column. It's basically a unique fingerprint for each person. We could have another customer named Jane Smith, sure, but her customer ID would have to be different. This rule is like the absolute foundation for making sure your data is trustworthy. But this is where the magic really happens. The whole reason it's called the relational model is because of how it connects these tables. And it does that with something called a foreign key. And you can see it right here perfectly. See that customer ID column in the orders table? That's our foreign key. It points directly back to the primary key in the customers table. And just like that, with one simple link, we've connected these two different sets of data. We now know exactly which customer placed which order. It's beautiful.
So Cod's idea just exploded. It got so popular so fast that he started to worry that companies would just slap the relational sticker on their old clunky products without actually following the rules. So to protect his vision, he published a set of rules, his 12 commandments, if you will, to define what being relational really means. He called them his 12 rules, but in a classic programmer move, he numbered them starting at 0. So rule 0 to rule 12 means there are actually 13 of them. You gotta love that. It's a great piece of trivia. Now, we're not gonna go through all 13, but these first few really capture the whole vibe. Rule 1 is the big one. Everything has to be stored in a table. No exceptions. No hidden files, no secret backdoors. This was a huge deal because it stopped the old chaos from creeping back in. And rule 2 is the guarantee. If you know the table name, the primary key, and the column name, you can find any single piece of data. It's all about order and predictability. So as these databases became the heart of every business, a massive new problem popped up. What happens when thousands of people or thousands of programs are all trying to read and write to the exact same data at the exact same time? This quote just nails it. It's a balancing act. Think about it. Two people are trying to book the very last seat on an airplane at the exact same millisecond. The system has to be fast, right? But it also absolutely, positively cannot sell that same seat twice. It's a constant fight between speed and getting it right. Now, the perfect ideal solution to this is something called serializability. You can think of it as the holy standard for making sure data is correct. It's basically a promise that no matter how messy and chaotic things get with everyone trying to do things at once, the final result will be the same as if each request happened one by one, in a nice, neat little line. But, and this is a big but, achieving that level of perfection can slow things down. So database engineers came up with different isolation levels that let developers choose their trade-off. Do you want maximum speed, even if it means there's a tiny risk of a weird data glitch? Or do you need perfect, 100% consistency, even if it means sacrificing a little bit of performance?
So after 50 plus years of development, of refinement, of tackling these huge challenges like concurrency, where does this old idea stand today? Well, the short answer is everywhere. The true lasting genius of the relational model is that it's declarative. What that means is you don't tell the database how to find the data, you just declare what data you want. You say, give me all the customers in New York who bought a blue shirt, and the database itself figures out the smartest, fastest way to get it for you. This separation of what from how is why it's still the invisible scaffolding holding up so much of our world. But the world of data is, well, it's changing fast. We have these massive, messy data sets, AI models, all kinds of new databases. The whole point of the relational model was to bring order to chaos. But now, as data itself gets more and more chaotic, is this 50-year-old idea of neat tables and strict rules still going to be king? That right there, that's the billion-dollar question for the next 50 years.